This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you in part by the Pro Mathematics Academy. In this video, we'll be looking at how to find the determinant of a 4x4 matrix using two methods, okay? So the first method we want to use here is method number 1, which is the traditional method for finding the determinant of a matrix, right? So here I'm going to say the determinant of A is equal to, taking the first row, right, we have 1 times what we sometimes call the cofactor, right? Here I'm going to choose -1, 0, 4, 1, 3, 0, -2, 1, 3, right? And then I minus 0 times the cofactor 2, 1, 0, 0, 3, 1, 4, 0, 3, plus -1 times the cofactor of 2, 1, 0, -1, 1, -2, 4, 0, 3. And our last term here is we want to subtract 2 times this cofactor here, 2, -1, 0, 1, 0, 1, -2, 3, 1. And we have this expression. So once we can evaluate each of these terms, right? Once we can evaluate each of these determinants, right? And without further ado, we'll recognize that here, this one is 0, so we don't need to evaluate this determinant. All right, so we're left with 3 other determinants, right? So let's go for the first one. So let's copy this one down. And we can write this determinant as -1 times 3, 0, 1, 3 minus 0 times 1 minus 2, 0, 3 plus 4 times 1 minus 2, 3, 1. Okay? Simplifying this gives us -1 times 9 minus 0 plus 4 times 1 minus -6, so that's plus 6. This is -9 plus 6 plus 1 is 7, 7 fours, 28. So here this gives us 19. 28 take away 9, right, is equal to 19. That's the first one. So now we need to go for our second matrix. Okay. So here, this one is going to be 2 times the matrix 1, 0, -2, 3, plus 1 times 1, 0, 0, 3, plus 4 times 1, 1, 0, -2. Simplifying this now gives us 2 times 3 plus 1 times 3 plus 4 times -2, which means we have 6 plus 3 minus 8, which is equal to 1. The other matrix we need to evaluate here is this last one, right? So now this one gives us 2 times the cofactor, 1, 3, -2, 1, plus 1 times 1, 0, 3, 1, right? Plus 0 times something. We don't need to evaluate this because 0 times this expression, it's going to be 0. So we don't need that one. All right. Continuing. So simplifying this one, we have 2 times 1 plus 6 plus 1 times 1, which is equal to 14 plus 1, which is equal to 15. Now, having all of these values, we can write down the value for our determinant as follows. So this is 1 times 19 minus 1 times 1 minus 2 times 15, right? Let's make sure we're entering the values correctly. Okay, so therefore this answer becomes 19 minus 31, which is equal to negative 12. Okay, so now that we've used method 1 to evaluate our determinant, we're now going to jump over to method number 2. Okay, so let's get a copy of our matrix here. Okay, and in this method, we'll be using elementary row operations. Okay, so let's go. So, and the purpose is to triangularize our matrix. So once our matrix becomes a triangular matrix, then we can stop and take the product of the terms along the diagonal. Okay, along the leading diagonal. So once we triangularize our matrix, we just take the product of the terms along the diagonal, and that is equal to our determinant. So now, this term is already 0. So the next term I want to eliminate is this one and this one. All right. So I'm going to take row 2, and I'm going to eliminate row 2 by using row 2 minus 2 times row 1. Okay, that's why I'm going to eliminate row 2, and to eliminate row 3, I'm going to say that row 3 is equal to row 3 minus row 1. After performing these transformations, I'll now write down my matrix as follows: 1, 0, minus 1, 2, 0, 0, 0, because I know I'm eliminating these terms. For this second term right here, we'll have negative 1 minus 2 times that, which is negative 1. 0 minus 2 times minus 1 gives us positive 2. And 4 minus 2 times 2 is 0. Right? Our next row gives us 1 minus 0, which is 1. 3 minus minus 1, which is 4. And 0 minus 2, which is minus 2. This row is still the same row, so we have minus 2 here, 1 and 3, right? So notice that this matrix is not the same matrix as A, right? But it is a transformed matrix, right? So we're transforming our matrix using the elementary row operations, right? The next set of operations I will perform now, I will try to eliminate this minus 2 and this 1, okay? So how can I eliminate that minus 2? I can eliminate the minus 2 by saying row 4 is going to be row 4 plus 2 times row 3. Okay, and here I take row 3, and I'll say row 3 is equal to row 3 plus row 2. Okay, performing these EROs then gives us 1, 0, minus 1, 2, because I haven't changed anything inside of the first row. 0, minus 1, 2, 0, because I haven't changed anything in the second row for this set of transformations. Right, but here this one becomes 0. This is still 0. Right, now I have 0, 0, but I need to figure out these other 4 terms. Now, for row 3, I'm simply adding the row above it. So here I'll add these 2 and I get 6, right? I'll add these 2 and I'll get minus 2. My last row, right? In order to get row 4, I'm using row 4 plus 2 times row 3. So here, this was 1, and I'm adding 2 times row 3. So 2 times row 3 in this case is 8. So this becomes 9 when I add them together. And for this last term, I'm adding 2 times negative 2 to my 3. So if I'm adding 2 times negative 2, that's minus 4. And if I add minus 4 to 3, then I get minus 1. Right? So I'm almost there. I just need to eliminate this 9. And once I eliminate 9 from the equation, right? Once I eliminate 9 from the equation, I'll then end up with a triangular matrix. All right? And that's our goal. So here to eliminate 9, I'll say that row 4 is equal to row 4 minus, right? And I have to use row 3, but what is the scalar that I'm going to use here? What is the scalar I'm going to use here to eliminate this 9? So I need a scalar times 6, right? I need a scalar times 6 here. So let's keep that as row 3. And what is that scalar, right? So here I'm going to say 9 minus k times 6 is equal to 0. This implies that 9 is equal to 6k, which means that k is equal to 9 divided by 6, which is equal to 3 divided by 2. Okay, so now I'm going to say that, let's put this one side. This was just some scrap work, which would help me to figure out what k is. So basically I'm saying row 4 is equal to row 4 minus 3 divided by 2 times row 3, right? So if I perform this set of EROs, I'll end up with 1, 0, minus 1, 2, 0, minus 1, 2, 0, 0, 0, 6, minus 2, 0, 0, 0. And I just need to figure out this last term, which should be what? Negative 1, right? Minus 3 over 2 times minus 2, right? I hope you guys are following. So this is minus 1 plus 3, which is equal to 2. So therefore I have my final term there, which is 2. So now I can say that A star is equal to 1, 0, minus 1, 2, 0, minus 1, 2, 0, 0, 0, 6, minus 2, 0, 0, 0, 2. Right? And it's now triangular. Okay? Which is now triangular. So the determinant of A star is equal to the determinant of A, right? Because I perform my EROs, guys, and here we have to make a special note that these EROs have to be performed a specific way, okay? But if you perform your EROs in this manner, you should get the same answer. So here, I'm going to say that the determinant is equal to 1 times negative 1 times 6 times 2, which is equal to negative 12, right? Which is the same answer we got when we did method 1. All right? That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.